I just sometimes feel like going head slap. So, again, I'm back with the controversial, apparently, S-9. What is S-9? So, people are saying I'm wrong. People are saying I'm right. Honestly, I'm wrong. And I'm right. And the other people, they're wrong and they're right. That is the problem. This is controversial, and it shouldn't be. And therein lies the problem behind what is S-9. For starters, manufacturers can't agree on what is S-9. And I'm going to show that with a pile of just random service manuals I pulled out of the filing cabinet. So, again, we'll go to the little chart, because this is the way it is supposed to be. I don't care what any of these service manuals say. Some of them are right, some of them are... They're not that they're wrong, it's just everything's relative. And they relatively, randomly, or arbitrarily pick a signal level to represent S-9 on the meters on their radios. The problem with every one of these manuals having a different level is, when the person using this radio, for this manual covers, talks to a person on, let's say, the radio that this manual covers, if they're both, let's say, 5 miles apart, and they're both using the exact same power, so if you measure the power at their antenna, they both had the exact same amount of power, and both of the meters are calibrated using the manuals for their, for their associated, the service manual for those associated radios, both the signal meters are going to read differently, because even the manufacturers can't agree. So that's why there was a standard that came out, which is what I use, and it is what everyone that works on radios should use. Pretty much all amateur radio operators, they know and they use that standard. We'll get into that in the end. But when it comes to CB radios, yeah, forget it. There's a lot of disagreement, and even in the amateur community, even amateur radios, these are factory service manuals. It's not like these are copies. These are your original glue-bound factory service manuals. Even Yaesu. You can go and pick up a Kenwood manual. I can go pull an ICOM manual out of the filing cabinet, and I'm going to see the same thing. Differences. And that's the problem. So, this is the chart we should be using for frequencies below 30 megahertz. And if you've seen the other videos, you've seen there's another chart for frequencies above 30 megahertz. But just for some examples to show what are the differences. So, this is a manual for a Yaesu FT101 series radio. And you can see S-meter adjustments. And they have some oddball setting in theirs. Then you adjust VR2 on, that's circuit board PB1183B, so the meter reads 25 over S9. But what's the input? Okay, connect a signal generator, antenna terminal, output of 50 microvolts. Ah, well that sounds right, and that is, okay? 50 microvolts is what you would normally adjust your signal meter at. The problem is when it comes down to what you're actually setting the meter to, they say 25 over S9. That's 25 dB over S9. That's not what it is. 50 microvolts is S9. So the Yaesu manual does not meet the international standard. We pull up even an older radio, Tram D201. Okay, factory, see, ring, or the heck you call that, spring bound, but it's meter. S-meter calibrate. Set generator output to 50 microvolts on channel 13, and adjust R429 S-meter sensitivity for S9 reading on the panel meter. Aha, finally we're right. 50 microvolts. But they made an error in this manual in the way that they said it, and that's part of what causes a lot of confusion. It says 50 microvolts, but it does not state, is that 50 microvolts under load, or is that 50 microvolts unterminated? It doesn't state. So that right there alone can cause some confusion, and I'll show that right now. We'll get to the other manuals in a minute, and the actual international standard. But I can demonstrate that confusion. So what I have set up here, so I'll disconnect this. So we have a BNC cable right here. It goes up to that verifications test set. I'm not going to change the output level on that. That's just going to stay the same. It's putting out a 10 megahertz signal at amplitude of 1 volt peak to peak. But the key is this signal generator, you can see it says 50 ohms right there. What it is expecting, because you can change the output impedance on this, and basically you're not so much changing the output impedance on it, but it knows what level to put out this jack, so you actually end up with that voltage at the end of your cable at whatever you have the termination set to. But I have it set to 50 ohms, okay? 1 volt peak to peak. So, if we hook that up to an oscilloscope, actually I'll just take the cable off and I'll stick the scope probe straight in there. So, we have an oscilloscope probe here, comes down to the oscilloscope, and I just have a little get that back in camera view. So there you can see, there's the cable to the oscilloscope, and here's a little adapter. So this is just a BNC to scope probe adapter. And I'm just going to shove that right in that output of that signal generator. Now what would you expect to see? The signal generator is putting out 1 volt peak to peak. You would expect to see 1 volt peak to peak down here, right? Well, you would be wrong. Because this oscilloscope and this oscilloscope probe are not a 50 ohm impedance. And you can see right there, 2.0608 volts. Yeah, 2 times the voltage. Now, we can easily change that and make it read correctly. Because remember, this signal generator is expecting to see that 50 ohm load. So that's what I have here. This is a 50 ohm termination, okay? So what that means is there's a 50 ohm termination in here, a resistor, but it also has an output. So it's called what is called a pass-through or feed-through termination. But that applies that 50 ohm load. So we'll disconnect. We'll stick that on the end there. Hook it back up. And magically, look at that. 1 volt peak to peak, which is what we're actually putting out. But that's because the oscilloscope, or the signal generator, is now seeing the 50 ohm load that it is expecting. It's actually seeing that now, so the voltage is correct. It's 1 volt peak to peak. But like I say, that's the difference. This configuration I have set up here is loaded. Okay, so when you see that, received voltage, that would be like, let's say, 50 microvolts. And when you get to EMF, EMF would be remove the termination, there is no load, that's unterminated. So that is electromotive force, okay? That's an unterminated. You're just reading it open. And that's where you get, but notice, that's 2 times, which is the same problem we have here. If I change that to, let's say, 500 millivolts peak to peak, okay, you can see we have 1 volt, so it's kind of like 100 to 50, but it keeps the numbers the same. And then if I add the load, we're going to see now half of that. Okay? We can see it's correct, 500 millivolts, but that's because we've added that termination. So, and it doesn't need to be a feed-through termination. I can use what I actually originally had set up here, and I'll get it hooked up, is a BNC cable. Okay. We can take a T adapter. So there's the cable. Take a T adapter. Hook that up. And then what I have, the other things that I have hooked up to this, okay, so there's the T adapter. I'm going to stick a female-to-female adapter in here. And this is a 50 ohm termination, just like this is a feed-through termination. This one is just a termination. There's nothing coming out the other end of it. It is just a 50 ohm termination. I'll stick that on there. And again, stick the scope probe in there. And let's put that back up to a higher voltage. Just make that 1 volt peak to peak again. So you can see, but it's reading correctly. 1 volt peak to peak. But as soon as I remove this 50 ohm termination, the voltage doubles. That's because unterminated, or EMF voltage, terminated properly, it matches. That's the whole problem. It's one of the problems. So I hope that actually demonstrates a little bit better in the real world what some of that means. But like I say, by this service manual not stating whether that's loaded or unloaded, the technician, me or you or anybody, is left wondering, because nowhere in this manual does it say that that's 50 microvolts at 50 ohm load. And you'll find other service manuals that will say 100 microvolts. But again, they don't say is that terminated or unterminated. Here's another manual. This is a fairly brand new radio, President John E3. It hasn't been on the market very long. They have it right in this one. Okay, alignment of the receiver, same as, so actually look at the setup here, same as one, so channel 20 mid-volume, but connect the HF generator to the antenna jack, adjusted to minus 73 dBm for S-meter display of S-9. And that's exactly what it should be. So they're using the correct standard. They're using the international standard in this manual. But if you go back honestly and look at some of the older President stuff, before they kind of reinvented themselves and came back into the market again here in the last several years, you look at older President manuals, you'll find different. It won't be that. They'll have different things written in some of those manuals. Here is a black box radio. So this is a Superstar 4900B. So this is one of those base station radios. Where is it in here? Right there, right by my hand. So signal meter. What do they say? Channel 19. 100 microvolts, minus 67 dBm. That's not the standard. That's not correct. It's not. It shouldn't be minus 67. But it's in the manual, so it is correct. So if somebody works on a black box, and a lot of the black box radios, that is what they specify. And if someone aligns your radio and they're using the factory service manual and they set it to minus 67 dBm, did we go out of focus? Hocus pocus, focus. What the hell happened to the camera here? There we go. It's back in focus now. It was taking a break. But that's the problem. Unless everybody uses the exact same standard, no two people's meters are going to read the same thing, even if both radios are receiving the exact same signal. There needs to be a standard. And there is. The problem is almost nobody uses the blasted thing. Or like I say, they make a manual, but it doesn't specifically say the load condition of the output. This one is just plain not the standard. This is not the international standard. Like what was written in this manual is correct if you assume that it's under 50 ohm load. That's the problem. You're still left assuming you don't know. So, another problem you run into depends on what signal generator you're using. I have some signal generators that have, I don't want to say they're questionable, but they have output levels, the way that they're calibrated leaves you scratching your head. Main problem there is, and Kenwood tried to clear that up. Kenwood Trio, okay? Radios made in Japan. Made over there for decades. They realized that the radios are being made in Japan. So they're being aligned in Japan. The problem is in Japan, they're using signal generators that were made in Japan. And they have their outputs on their signal generators calibrated to, well, it's not so much calibrated, but they use a different scale than we use here in the United States normally for an output of a signal generator. So Kenwood at least knew that, well, we need to make sure that we clear this up a little bit. So even in their service manual. So this is just a printout of a page out of a TS440S service manual. What they did was they put a little chart in there to try and clear up some of that confusion. Okay, so you can see the Japanese signal, and I have used to have it actually have one of them on this bench years ago. I had a leader, and I still have them. A leader AM/FM stereo signal generator. I mainly use those for working on stereo receivers. But anyhow, but it is a signal generator made in Japan, and it has a scale calibrated just like this. Okay, it just says dB. We don't like that. dB, when you use dB, it's referenced to something. there is no reference here. They kind of arbitrarily came up with this. That's why I really don't like it. But like I say, Kenwood was at least nice enough to put in the service manual if you're using a Japanese, and the SG stands for signal generator. But if you're using a Japanese signal generator, whatever it is here is the same as if you own an American signal generator. 40 dB on a Japanese signal generator is the same level as 50 microvolts on an American signal generator. So like I say, they did try to clear that up a little bit. Now, here's a guy that did a little paper on this, and you can find, and I did actually in the video previous to this, when I went back and pinned a comment at the top of the comments section of that, with a bunch of links. I think one of them actually is to this page. But Larry does a good job kind of describing a little bit of the history of signal meters, the relative signal, or the readability strength tone, or RST, developed in the early 20th century, around 1912, blah, 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 the whole 9 yards. But it goes through, and there's confusion. That's the problem, though. It's right there is the key words. It's a subjective system, and it depends. Who's radio? But you can see in 1981, the IARU Region 1 Technical Recommendation R.1 came out. And now we're not even just going to look at his, and I'll leave a link to, I don't think it might have been this page. I'll leave a link to a page that has a link, because this is actually a PDF document, or I'll leave a link in the description for this document, for this PDF document, so you can download it. This is the IARU Region 1 technical document, okay? It's chapter 10.1.2 in the HF Manager's Handbook, version 8.1. This was printed in January 1994, and this is still the same. Like I say, the standard came out in 1981. This document here is just reprinted. It was a manual that was printed in 1994, but it's still the same. And this is what everyone should use. If everyone uses this international standard, everybody's S-meter would read exactly the same. We wouldn't have this confusion of this alignment procedure is different than this alignment procedure is different than this alignment procedure is different than this alignment procedure. And honestly, even this one, this one's here because I just worked on that radio, and this one probably being a Cobra, and actually Cobra in this time frame, you see this is a factory original Cobra service manual. But back then, Sam's actually printed the manuals for them, because you can see right now, Howard W. Sam's. They were actually the ones that printed these, but I can pretty much guarantee it's going to say 100 microvolts. Yes, right there it is. Output signal generator through a 0.01 microfarad capacitor to antenna jack, because this is in sideband. So 20, the signal would be at 27.186 megahertz, no modulation, but 100 microvolts for S9. Again, 50 microvolts or 100 microvolts. These manuals were written with those levels unterminated, which I just showed at the scope there. So, that would be 100 microvolts here. That's 100 microvolts EMF, which is equivalent to 50 microvolts terminated, or minus 73 dBm. But like I say, that leaves question in you don't know. It doesn't say terminated or unterminated, so you're left wondering. That's what this international standard is for. They came out with this, so everybody uses the same exact standard. Some of them do. Honestly, it's probably half and half. Half do, half don't. It's gotten better over the years, but it's still not right. So, as before, as I said, I'll have to reach over here and grab it. Oh, where is my other chart? I've got these two little printouts that I keep handy, because there are, like I say, there's two charts. One for frequencies below 30 megahertz, one for frequencies above 30 megahertz. And that's just what it says here, on bands 30 megahertz, meter deviation of S9 corresponds to an available power of a CW signal generator. CW means continuous wave. Generator connected to receiver input minus 73 dBm. On other bands above 30 megahertz, that would be this chart here, this power shall be minus 93. So actually, if you look at this chart, S9 is minus 93 dBm, okay? But this explains it. Terminated, on HF band level, minus 73 dBm, 50 microvolts over. See, and that's where this is a technical document, so they make sure that they clearly spell this out. On HF bands, this is the HF bands. Anything below 30 megahertz that's the HF band there. Well, within reason, until you get really low in frequency, then you're in the VLF frequency band. But on HF bands, it's minus 73 dBm, which is 50 microvolts over 50 ohms. That's what's nice about this document. It clearly states that 50 microvolts is over 50 ohms. It states its condition. Is it terminated or unterminated? And then, same thing for on higher bands, minus 93 dBm for 5 microvolts over 50 ohms. And if we look at this little chart here, you can see S9 is 5 microvolts or minus 93 dBm. And again, but you can see here, this has other levels. Like I say, you can read it in dB microvolts. You can take power measurements, so you can do it in wattage. Alto, femto, pico, nanowatts. But this is the document. This is what all radio manufacturers should strive to do. And actually, here on the second page of this document, and it says, we hope that the current recommendation be allowed all equipment manufacturers so that it's not too distant future, one will know how to interpret the strength report of another station. Yeah, hopefully, unless something's enforced, and that's the problem. IARU, it's not like they're a government agency that can force every radio manufacturer. They're not a global force that can control all the radio manufacturers in the planet and force them to use a single standard. They can just, we hope. Unfortunately, and right there, society should advise as much as possible their members about equipment manufacturers. They're suggesting to people, tell your manufacturer the next time you make a radio, make sure you use this standard. That way my radio meter reads exactly the same as the guy next door or the guy on the other side of the planet. And here again is basically this doesn't have as many columns, but the same chart, S9 minus 73 dBm, 50 microvolts for frequencies, HF bands, so frequencies below 30 megahertz, and for bands above 30 megahertz, for S9, it's minus 93 dBm, or 5 microvolts. So I hope that helps to clear up the confusion a little bit. Like I say, the proper setting, especially if you're working on a CB or an export radio or an HF amateur radio, it's minus 73. It's not minus 67. It's not even correct to say it's 50 microvolts or 100 microvolts. It's right. That's right. If you say set your radio to 50 microvolts, or someone says set your radio to 100 microvolts for S9 on a radio, you know something? They're both right. The problem is they didn't phrase that comment properly because they didn't state the load condition. And matter of fact, I think I still have that in the filing cabinet here beside me. Yes, this page, where I had showed. That's why I prefer when you write down microvolts, okay, you state the condition that measurement was taken under. Because 50 microvolts is minus 73 dBm. But you can't, but if you just say 50 or 0.1 microvolts, you can't be sure is that loaded or not. That's why the proper way to do it would be to write down 100 microvolts EMF or 50.1 microvolts PD, meaning terminated. Very important that you know that load condition. So I hope this helps to clear it up a little bit. Like I say, there are lots of standards. And I can go, honestly, through even more service manuals. Even in amateur radios, I can find lots of different settings. Some of them, like the Yaesu FT, or no, that's the FT107, I think. I think they have you set it some weird-ass level, but you actually calibrate the meter at like plus 40 dB over S9 or something. Like I say, even the amateur radio manufacturers, a lot of them, now they've gotten better over the years. Got to remember, this specification, came out in 1981. And like this Yaesu manual, when was this actually printed? Should be a publication date, I would think, in here somewhere. Maybe not. Well, isn't that nice of them? There's actually no publication date here. I was just trying to see. Yeah, you know, this would have been early around the time of that document coming out. Honestly, I don't see a date anywhere in this blasted thing. It's kind of screwy. Most books and manuals at least have a publication date. Guess Yaesu didn't think they needed to do that. They have a date on the schematics? No. Back cover, maybe? No, nothing on back cover. No engineering notation with a date on them. But yeah, like I say, that's the problem. Earlier radios, they hadn't come out with that international standard yet. So yeah, a manual like this, yeah, maybe they're not following that because it wasn't clear. But even today, it's still, if you buy a brand new radio, like a Linko, they set theirs to some weird level. But when I do a radio, that's the two charts I use. These charts are the international standard, the IARU's standard, okay? This is the chart right here that covers both HF and VHF, or anything over 30 megahertz. This is it right here. Like I say, I'll leave a link to this PDF document, and if everybody uses the international standard, then there will be no confusion. There won't be any arguments. There won't be any misreading, or, you know, why does mine read S-9 when yours reads S-7 and the guy down the street reads S-20 and we were all listening to the same guy? It's because you weren't using the, you know, those radios, if they weren't all, have S-meters calibrated to the international standard, they're all going to read different. So that's kind of the whole point. We're all wrong, we're all right. It honestly depends on the service manual. If you're using the service manual to align the radio and you adjust it to minus 67 dBm, well, you're right. You're doing what the manufacturer recommended. The problem is the manufacturer is the one that's wrong. You're not wrong for following the manual. You're doing what you should be doing. You're following the proper alignment procedure. The problem is the manufacturers aren't doing what they should do. You should use international standards. So I hope this clears it up even a little bit more. Like I say, it's something so simple can be so confusing, is very frustrating trying to explain it. So I hope this explains it a little bit better. The differences, I demonstrated loaded and unloaded signals, how that actually affects it, so you could actually see it on a scope. Like I said, here's the standard, and I demonstrated in several service manuals that, yeah, everybody has kind of an arbitrary, it's just whatever they felt like using. Some of them use the proper specs, some of them don't, some of them aren't clear, they don't state loaded or unloaded, and other manufacturers just use whatever the heck they feel like using. And it varies. Yaesu is a good example of that. Over the decades, if you go through service manuals for Yaesu radios over the decades, their S-9 level is different. Depends on what model radio you're using. It varies. Same thing with Kenwood. Actually, Kenwood Trio radios. You can go through radios they've made over the decades in the service manuals, and you'll find a couple different signal strength levels that they give for S-9. It's just not following the standard. Like I say, amateur radio manufacturers have gotten a lot better at it because of the international standard. They're trying to adhere to that. But even still, like I say, there are some out there that don't. This is what we should be using. This would make it completely 100% non-controversial. There would be no controversy if we all use the exact same standard. So I hope that helps. Hope it clears it up. Feel free, leave comments below.